You know how your favorite apps just seem to know what to do? That's not magic. It's all about controlling the flow of the code. So, in this explainer, we're going to break down exactly how programs make decisions, repeat stuff, and, go way beyond just a simple to-do list. So, let's kick things off with a big question. Is coding really just a fancy to-do list? A bunch of instructions the computer just follows from top to bottom without asking any questions? Well, yeah, in the really simple cases, maybe. But the real magic, the real power, that happens when we totally break free from that straight line. Okay, picture the most basic script you can imagine. It's pretty much a one-way street, right? The code just runs from the first line straight down to the very last one. No detours, no do-overs, no second thoughts. It's simple, sure. It's predictable. But let's be real, it's not very exciting, and it's definitely not useful for solving complex problems. Think of it like a really basic recipe. You follow the steps, one by one, and poof, you get a cake. But what if you want to add nuts? Or what if, oh no, you run out of sugar halfway through? A simple to-do list just can't handle those kinds of curveballs. Real life is messy, and our code has to be smart enough to handle that mess. Here's an analogy for you. Imagine you're on a road trip, just cruising down this long, straight highway with absolutely no exits. Yeah, the driving's easy, for sure, but you're missing out on all the cool stuff. The scenic detours, the little towns just off the main road. That's exactly what it's like to write code without what we call control flow. Okay, now flip that. Imagine you're driving in a super busy city. You have to make decisions constantly, at every single turn. Left or right, stop for the red light. Maybe you gotta pull over because the engine starts smoking. That's the kind of dynamic, responsive thinking that modern programs really need. So how do we give our code that ability to navigate those crazy city streets? The answer is something called conditional statements. You can think of them as the GPS for your code. They help it make smart decisions at every single intersection it comes across. At its heart, a conditional statement is really just the code asking itself a simple yes or no question. Stuff like, hey, is the user logged in? Or is the shopping cart empty? Or maybe, is this player's health below 0? And the answer to that question, yes or no, true or false, is what determines which path the code takes next. It's literally like a fork in the road. The code checks the condition. That's the road sign. And then it chooses a path. If the condition is true, boom, it goes one way, and it completely ignores the other route. If it's false, it takes the other path. It's so simple, so elegant, but unbelievably powerful. And this right here, this is a complete game changer. I mean it. With conditional statements, our code can finally react to different situations. It can show a nice welcome back message to a user who's logged in, or it can show a login form to a brand new visitor. That's the power of intelligent control flow. Okay, so making choices is great, but what about all those times when you need to do the exact same thing over and over and over again? I mean, imagine you're a teacher and you've got 100 assignments to grade. You're not going to write out a completely new grading plan for every single one, are you? Of course not. Exactly. It's kind of like cleaning your room. You don't just pick up one sock, step back, admire your work, and call it a day, right? No, you keep going, you keep picking things up, putting them away until the whole job is done. And that right there is the fundamental idea behind loops in programming. Loops are the true workhorses of programming. Seriously, they let us do the same action on a huge collection of items without ever getting tired. You need to send a personalized email to 1,000 subscribers. A loop can do that in a flash. But how does a loop know when to stop? It's all about the condition. Just like you check to see if the room is actually clean, the loop is constantly asking a question. Something like, hey, are there still items left in this list? And as long as the answer is yes, it just keeps on chugging. It's such a simple but brilliant idea when you think about it. The loop will just keep running its block of code as well as its condition stays true. The very moment that condition becomes false, like say when the list of items is finally empty, the loop stops and the program just moves on to the next thing. And, well, there you have it. You've got conditionals for making decisions and loops for repetition. With just these two fundamental tools, you've basically unlocked the ability to write code that isn't just a boring set of instructions, but a smart, dynamic program that can genuinely seem to think for itself. So, with conditionals, you're making your code smart, right? It can react to changing data. And with loops, you're making your code incredibly efficient, able to perform massive tasks with just a few lines of code. Put them together, and you have an absolutely powerful combination.
This is the real difference between, say, a wind-up toy and a self-driving car. A wind-up toy, it just follows one simple path until it runs out of energy. But a self-driving car, it uses sensors and logic to constantly make choices and repeat actions, navigating a super complex world. With control flow, your code can do the exact same thing.
All right, are you feeling ready to start building your own smart programs? Awesome. Let's take a quick look at the actual tools you'll be using in Python. These are the specific keywords that bring all these powerful ideas to life right there in your code.
So these are basically the keys to the kingdom. For decisions, you've got if, elif, and else to check conditions and pick a path. For repetition, you've got for, which lets you loop through a bunch of items, and while, which just keeps repeating as long as a condition is true. And then you have other keywords like break and continue that give you even more fine-tuned control, letting you, say, stop a loop early or just skip to the next item. But here's something you've absolutely got to remember. Your code is only as smart as the questions you teach it to ask. In the world of programming, we call these questions Boolean expressions. They're just simple statements that boil down to either true or false. And they are the absolute brains behind the whole operation. They power every single if statement and every while loop you write.
So what's the bottom line here? It's that these two core ideas, conditionals and loops, are the fundamental building blocks of pretty much all complex programs. It doesn't matter if you're building a video game, a data analysis tool, or the next huge social media app. You are going to be using these concepts to make it all happen.
So there you have it. You now know the secret to writing smart, dynamic code. The only question left is, what are you going to do with that power? What amazing things are you going to build? The possibilities are, and I mean this, truly endless. So go out there and create something awesome.